So let's get started. Bit of introduction about me. I'm the CTO of Last9. I have worked on a lot of technologies over the last few years, starting from mainframes to kernel programming to cloud systems, etc., etc. So yeah, I'm happy to talk about any of these as well. And like when I'm not coding or doing technology, I'm either playing tennis or playing Dungeons and Dragons or revising some old physics stuff, right? So, okay. So let's look at a typical observability product that's out there, right? What happens is you have your agent which is sitting on your machines, or either there's a SDK in your code, it is shipping the telemetry data, either logs, metrics, traces, whatever. And then it's going to the storage of whatever product you're using, right? On top of that, you have a kind of a query layer where you can query the data or something like that. And then you have a dashboard layer, which is essentially the UI layer of that particular product. This is a very common architecture of any observability product out there. If you look at how the counterpart for the open source world, the Grafana kind of world is, for metrics, you have Prometheus exporters, then the data is stored either in Prometheus itself, or you have Thanos, Victoria metrics, etc., etc. The language layer is PromQL, right, to query metrics, and then the UI layer is either the alert manager of Prometheus, or you have Grafana as a visualization layer typically. For tracing, you embed tracing SDK, whatever it is. The data goes into the Tempo storage. You have TraceQL as the language, and again on top you have the Grafana Tempo plugin. That's typically how you access it. For logs, you have Promtail, or there are other ways of getting the logs in, but essentially they go into Loki. The language is LogQL, and again on top the visualization is like a plugin inside Grafana, typically. Right? This is the open source world if you are managing it yourself and you're able to handle the scale fine. On the enterprise side, typically where the scale grows larger and it gets more and more difficult to handle it in-house, or handling it in-house itself becomes a full-time job, right? Or you need to start a mini company inside your company just to handle the scale. But then you have products like you have Datadog. For APM, Honeycomb is one of the popular products, and for logs, you have Sumo Logic or other log applications, Splunk, etc. But again, if the architecture is very similar. Datadog will have its own agent, they have their own storage, and on top of that, they have their application. Similarly, for tracing, Honeycomb, you have the tracing SDK. They're going to get the data again in their own storage, and they have the application on top. For logs, same story, ingest data, log storage, application, and query on top of that. Now, and this is the problem with this, and this is a problem that we actually see day to day when we talk to customers, right? Is these different types of data, telemetry data types, which are in different applications, right? They are in their own silos. And it's very difficult to ask questions regarding your system which encompass or which need data from all three applications or all three data stores. Right? For example, if you want to know what's the load and CPU of the pod which emitted this log line at the time this log line was emitted. These things are important when you're trying to debug and figure out what's happening. Then what you have to do is, okay, from here you have to take the pod ID, go to another application, put it over there, click, click, click. By that time, it's already 10 minutes, your VP is breathing down your neck. Why isn't this fixed already? Right? We are losing revenue. Another example, if you're using a tracing product, is you see a bunch of 5xx metric, the 5xx metric really shoots up suddenly, and you want to see, okay, what are the traces related to this 5xx? Again, if the data is not in a single place and correlated, either it's going to be impossible, or even if it becomes possible, it's going to take a lot of time. You're going to have to do multiple queries yourself and get that data. I mean, I hope you get the picture, right? Now, all this I've told you is with existing applications with the way observability has been happening for the last 10 odd years. Looking ahead, right, there are a lot of AI-based ops products and ops use cases that are coming into the market. And these are very specialized use cases. We are going to see a lot of product tackling specialized verticals like cost optimization, automated RCA creation, etc., etc. This is going to be replicated n times over. Each one of these products is going to have their own agent that you're going to have to install. They're going to take data and put it in their own storage, right? And they're going to build their own application on top. And we're already seeing this, right? We are talking to companies who are building AI-based systems. They are replicating the entire data pipeline plus storage stack themselves just to have to be able to deliver their use case. Right? They are good at the AI part, but today they have to build the entire stack underneath by themselves. And this again is a problem. If you draw a parallel with the data engineering world, right, on top of which all the AI revolution has happened, there have been layers like Databricks and like other platforms which give you a data platform on which you can build. And this platform is not just data storage, right? There are other things that we'll see that are needed in that platform. Yeah, so like I said, each one of these, their agent is going to collect, filter, and send, and then their storage is going to basically have these 4 types of data types in terms of telemetry: logs, metrics, traces, and events. Or typically, it's called the MELT stack. All of them end up repeating or reinventing the wheel because they have to. Not just that, if you're a consumer, I mean, none of this is free, right? Each one of them is going to charge you for the bandwidth. Each one of them is going to charge you for the storage, for their own query engine, and then their application on top. Even though you're going to see a single bill from each vendor, essentially they are charging you for all of this, right? Unless they are running into losses. Right? And in the end, it's this cost that is going to add up that is going to be borne by the end user. Right? So if you look at the problem with today's landscape, I'll just summarize them. Right? Everyone is reinventing the data store layer. Everyone is installing their own agent. Everyone is locking in your telemetry data into their product, into a silo. The costs are adding up. And today when you talk of correlation, it is just limited to people loading dashboards side by side and trying to figure out the information, common information within those dashboards. Like, having multiple monitors is not correlation. And there's amazing progress, like I said, happening in the whole AI world for ops as well as other domains. But everyone is building their own Databricks layer today. Right? So what's the solution? I mean, there has to be a better way. The way that Last9 has taken is basically we have a telemetry data platform, which is the core platform layer, on top of which the applications are built, right? So we'll go step by step, and I'll quickly explain what the telemetry data platform actually means on the ground. So firstly, you have a universal agent to collect, right? Open telemetry has matured over the last couple of years. It is improving day by day. It's becoming popular and it's sort of also becoming the de facto standard. So you can easily have one agent which is collecting all these different data types and shipping it to one or more sources. Then you have in blue the data source or the data warehouse layer, but there are important aspects about this. One is that at ingest, it must adhere to open standards and protocols. Right? You can't have a proprietary ingest format. I mean, you can, but then it's not really truly a platform that you can leverage. It obviously has to have optimized storage for logs, metrics, traces, and events. But on the query side, it also needs to support standard query protocols like PromQL, TraceQL, right, LogQL, all of these. And then on top of that, you can have your applications, right? Not just the proprietary application stack, but also it has to be compatible, or the open source ecosystem also should be able to use this platform, right? Otherwise, again, you are going into a vendor lock-in situation. But just this much is not enough. As from experience, what we have learned is people want to have control over their data. When you're talking about a telemetry data platform, the control over costs, what they want to ingest, and how they want to shape the data before it actually goes into the storage is very critical, right? So you need a sort of a control plane. In the data engineering world, you have this notion called as ETL, right? Extract, transform, load. What's the equivalent in the telemetry world? If you truly want to build fast and good AI kind of applications on top, you need a data platform to have that ETL, which is in your control, right? So things that you can, on the telemetry side, things that you can or actually need to do at the ETL layer is you should be able to drop certain data, right? And because otherwise the alternative is you go to every developer and say, okay, change your line of code because our data ingestion is going out of our budget, right? But if you at a control plane, you can drop the data, that's really useful. You should be able to convert logs to metrics, because if you look at the use case of evaluating alerts or any kind of evaluation rules, you have to do it on metrics, right? Anybody who's doing evaluations on top of logs or traces directly, right, is basically doing an inferior job. You have, I mean, the difference is in like 100x when you do evaluations on metrics. Very simple, because metrics are numbers, and comparing numbers is like way faster than parsing numbers out of a log or a trace and then doing the comparison, right? So for all alerting kind of use cases, you have to extract metrics that are useful out of the other data types like logs and traces and events. You need to be able to enrich data, like add certain attributes that are critical to your domain and your product. PII is a very important part that comes over here. You should be able to redact PII information, like mask it before it actually goes into storage. At the enterprise layer, this is something that's really needed. And then some control mechanisms on the data itself, like surge protection, right? Whenever you, like one of the most common complaint is somebody instrumented something in my code, and Datadog sent me a bill which was like $10,000 more than normal at the end of the month, and I had no idea, right? And if you are talking of a true telemetry data platform, you need this kind of controls and protections built into the ingest layer itself, so that either you get alerted or it's just dropped, it doesn't allow you to do it. And the control should be in your hands, right? Not decided by somebody who's building the product. The other important part of a telemetry data platform itself is, I mean, we saw that you have a common open standards query layer, but if you're saying you're a data platform and you want people to build applications on top of you or accelerate them or give them the ability to quickly iterate and build applications on your platform, you also have to provide certain things at the UI layer. So for example, you need a dashboard layer and an alerting layer that people can embed in their applications. Otherwise, they are going to have to again reinvent the whole thing of, oh, I have to write the front end for plotting this chart, right? Or I have to invent the front end for showing this alert and where it is being fired, and so on. So that API-driven embeddable UI layer is also an important component of a platform like this. And finally, one of the most important pieces that BC is missing today is what we call a semantic attribute layer, right? I'll give you an example. Let's say you are a SaaS product and you have something like communities, right? Or you have, I don't know, a vendor, right? Or a tenant or something as part of your domain, your product domain. Today, the observability world does not have these concepts embedded first class into the features that you have, right? For example, across logs, metrics, and traces, you don't see a community ID which means the same everywhere. And that's natural because let's say you are an application developer, you are emitting a log line, and you decide instead of community ID, I'm going to say community capital I, capital D. Whereas somebody who's instrumenting metrics is going to do it community underscore ID, right? To really have true correlation across all the data types, you need to get these semantic attributes standardized and meaning the same thing. So different solutions have been tried, but most of them try to do it at the query layer, which makes it very suboptimal. If you can do it pre-ingest, like along next to the control plane itself, then before the data is ingested, if you have standardized the token community capital I, capital D across your organization, then in your metrics you will see it like that. In your logs you will see it that way. In your traces you will see it that way. And this is absolutely important when for MTTR, right? MTTR basically stands for mean time to resolve. So when something goes wrong, how fast can you get your system back on track? And to do that, you need to have this product knowledge or attributes that directly map to the product embedded directly in your observability data. Right? Otherwise, again, you keep on searching, then you have, some people have a list of saved queries in one product, then they are going to go, what's the corresponding saved query or community ID over here, and so it just becomes a mess. If you truly want a single pane of glass where all the information comes to you at the click of a button, you have to have this mapped out before you start querying it. Right? So this semantic attribute mapping is a very important component. And the other important thing about it is that the embedded UI layer that I spoke about, that needs to be aware of the semantic mapping. Right? For example, if I have a dashboard widget and I say I want a community ID variable in that, right? It should understand what community ID means. Right? So there has to be a cross correlation from the ingest layer to the UI layer as well. Okay, so what I described till now was like end-to-end or the components of what is really needed in a telemetry data platform, which we are building at Last9, right? But all of this, I mean, all of this is a lot of work, right? A very central component of this entire data platform is the actual data warehouse, where you're going to store the logs, metrics, traces, and events, right? And for that, we are completely leveraging ClickHouse today, right? See, because we want to focus on the data platform and the end user workflows and the end user use cases, right? We don't want to reinvent the wheel when it comes to building a high scale data solution, data warehouse solution. And so that is where for us, ClickHouse comes in, and it's a very important and integral part of our solution today. So why ClickHouse? And we have gone through a few iterations, right, of trying different data warehouses and so on. But I mean, rather than going through the whole long journey, I'll just summarize why really ClickHouse works the best for us. Firstly, because I have to be politically correct, I have to add one of the, but it is the best performance to dollar that's out there in the market for the use cases that we have. Not just performance to dollar, but it is really fast in the absolute sense. If you get your data modeling correct, right, and for each of these data types, you need to put in a bit of thought on how you're going to model that data. But once you do that, it is really blazing fast, and compared to the competition, obviously. It scales really well. We don't have to be bothered about that. Like, for example, just for log lines, at Last9 today, we are ingesting about 480 million log lines per minute. And absolutely, like ClickHouse is just scaling, no problems at all. It has, I mean, this was covered in the last talk, but it has engines and data types for data modeling facilities for each of these data types, right? And because it's all of these can be done in one store efficiently. You can actually, I mean, when I say semantic mapping, right, for example, the data store also has to be common, right? So having a data store where we can model all these 4 data types of telemetry is essential to be able to do this semantic mapping, and that's something that ClickHouse allows us. The query interface of ClickHouse is SQL, something that developers are very used to. But what that has enabled us to do is write translations like from logQL to SQL, traceQL to SQL, promql to SQL, right? So that we can give a open standards query protocol interface to our users, but behind the scenes we can easily convert it to SQL. And more importantly, I mean, my whole theme is that people should not be reinventing the wheel. It allows us to not reinvent the wheel in that critical data warehouse layer. To summarize, the landscape of observability products today, proprietary data silos are really killing observability in terms of experience as well as in terms of cost. Today, there's no Databricks equivalent for the telemetry world. That is still missing. And what is happening today is that people are getting data to individual apps rather than getting apps to the data, right? And that really needs to change if people really want to do real operational intelligence on top of telemetry data. Right? So we have already started working with a few startups, like when I said it, if I go back a bit. I don't know whether it's visible over here, but like I said, in addition to the core apps that we have as part of our offering, we have started working with other companies to get third-party apps onto the Last9 telemetry data platform as well. For example, we are working with a company which gives you recommendations for cost optimization based on your telemetry data, right? Now, we are not AI experts, right? But we have the platform on which you can build your AI application, right? So feel free to get in touch with us if you have an idea, if you're already building one of these apps. We'd love to talk and see how we can collaborate. And yeah, I think that was it. Check out, scan the QR code. You can check out the blog that we have at Last9. Some interesting stuff there. We are hiring, so if you're interested, just shoot us an email. So we are around. Feel free to get in touch and just say hi or discuss anything. Thank you.